Alright, but today we're going to look at similar polygons. Similar polygons are polygons, which if we haven't really talked about that since forever ago, since like middle school. Polygons are just flat, two-dimensional shapes that are made with segments. So they're not going to be curved. They won't be like circles. They'll be flat, so they won't be three-dimensional like a cube or a prism. Okay? And then they also have to be closed, so they can't be like an angle symbol. They have to have that third side. They have to be closed. So that's what makes a polygon. Examples of polygons are triangles, quadrilaterals, pentagons, hexagons, octagons, polygons. Okay? Are polygons. Today we're going to look at similar polygons. Polygons with the same shape, but not necessarily the same size. Okay, that's what a similar polygon is. The symbol for similar looks just like the congruent, but without the equals. It's just this little squiggle. Okay, so you would say triangle ABC is similar, and you would do this little squiggle to triangle DEF, or something like that. Okay, so it works just like a congruent symbol. It's just letting you know that they are the same shape, but they're not the same size. And when I say the same shape, that doesn't mean that they're just both triangles. Because triangles, even though they both have you have two triangles with three sides each, they might not be similar. One might be an acute triangle, one might be an obtuse triangle, so they're not going to be the same shape. They're going to be both triangles, but one's going to be a wide triangle, one's going to be a smaller or narrower triangle. Okay? So it's important that they really are similar. You'll know they're similar because they're going to have two distinct properties. Two polygons will be similar if and only if their corresponding sides are proportional. So corresponding is important. They're corresponding, so sides that are in the same spot are proportional. And their corresponding angles are congruent. If you don't want to write out the whole word congruent, you can use the symbol. Remember, your symbol for congruent is like the similar, but with an equal underneath it. Okay? And again, it's important that they are corresponding. Okay? So we already know what it means to be congruent. They have the exact same measure. But proportional, we haven't really talked about that with shapes. Yesterday we talked about that a proportion are two equal ratios, two equal fractions. So what we're going to do is we're going to take corresponding sides from our two figures. We're going to set them up as ratios and see, do they all equal the same thing? If they do, then since the ratios, the fractions are equal, that means they are proportional. Okay? All right, so let's look at this first example. It says, is quadrilateral ABCD similar to quadrilateral JKLM? It is going to be important that you read the names of your shapes because the order they put the letters in is important because I know these four letters in order match these four letters in order. Okay? So that is going to be important to pay attention to as we keep going because sometimes our shapes aren't like this one where they're sitting nice and exactly the same next to each other. Sometimes they've been rotated and reflected and all the things. Okay? So we want to say, are these two figures similar? Well, if they are, then their angles will all be the same, the corresponding ones. So that means the angle's in the same spot. So when I look at my first letter here, angle A, and I compare it to the first letter here, angle J, when I look at angle A and angle J, are they the same? Yes. Yeah, they're both 90 degrees. So these are congruent. Okay? So then I look at my second letter. My second letter is angle B. It matches up with my second letter, angle K. When I look at B and K, are they the same? Yes, they both have a single arc on them, which means they're the same. They have matching arc marks. All right, then my third letter here is C, so angle C. Does it match up with my third letter, angle L? angle C and angle L, are they congruent? Yes. They both have double arc marks on them, so they are congruent. And then my last letter here is D. It should match up with my last letter here, M. Are angle D and angle M the same? Yes, they both have triple arc marks, so they are congruent. So my first half of this problem is done. My 4 angles are the same. And if you were doing this on a homework assignment, I wouldn't need you to necessarily write that out. You can just look at them and see that the 4 angles match. Okay, but in your notes, I think it's important that you see exactly where we're going. Okay? So that's only half of the situation. We also have to show that my corresponding sides, when I make them ratios, they equal each other. That means they're proportional. Okay? So again, we have to look back at how we name our shapes. My first shape, ABCD, that tells me that AB is one of its sides. AB is going to match up with which side over here? JK. Now, since I'm looking at ABCD similar to JKLM, I'm going to put ABC in the top of my fraction, because just like yesterday we did students to teachers, so students went on top. We did electives to non-electives, so electives went on top, right? So since this one comes first, it's going to go on the top of my fraction. So AB is going to go on the top of my ratio, and it's going to go over JK to complete the ratio. So those are corresponding sides as a ratio, okay? So then I look at my next pair of letters. So after AB comes BC. Since it's first, it goes on the top. What is BC going to match up with? KL. Okay. Then my next 2 letters are CD. What's CD going to match up with? LM. And then what's my 4th side? Yeah, right? So then my outside letters, DA or AD, however you want to say it, matches with JM. So I have all those ratios. If they are all equal, then that means yes, they are proportional. If one of them is wrong, then no, these are not proportional. They all have to be the same in order to be proportional. Okay? So let's plug in our numbers and see if they're all the same. AB is 8. JK is 14. BC is 8. KL is 14. So those are equal. That's good. CD is 8. LM is 14. So that's good. Those are all the same. So far, so good. One more. AD, is 12. JM is 21. Are those the same? How can I find out if they're the same? Simplify, right? Let's reduce those fractions. 8 over 4 reduces to 2.
This is 14.
Oh, sorry, 8 over 14 reduces to 4/7. So these are all can be rewritten as 4/7, 4/7. 12 over 21 reduces to, oh, yay, 4/7. So they do all reduce to the exact same thing, which means the angles are congruent and the sides are proportional. So when it says, is quadrilateral ABCD similar to quadrilateral JKLM? My answer is yes. Quadrilateral ABCD is similar to, I'm using my similar symbol, quadrilateral JKLM. because the angles are congruent and the sides are proportional. Questions? All right, scale factor, the ratio of the lengths of corresponding sides. So ratio is just a fancy word for fraction. It's a fraction made from the length of the corresponding sides. Well, remember that's what we set up here. We said AB, the first two letters, corresponds to JK. So this is a fraction made with corresponding sides. 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 So all of these fractions, when they get reduced, that reduced answer, guess what that is? That reduced answer, guess what that is? Oh, it's a scale factor. How'd you come up with that? It's the scale factor. Okay? So on my examples, when it says, what is the scale factor of quadrilateral ABCD to quadrilateral JKLM? So this one to this one. Well, we already did this figure on top for this figure, ABCD to JKLM. So we already know the answer. The scale factor is 4/7, or 4:7. But look at the next one. It says, well, what is the scale factor of quadrilateral JKLM to quadrilateral ABCD? What do you think is going to happen? Yes. Yes./What's going to happen? Yeah, it's just going to flip over, right? So my scale factor then is going to become 7/4. Because that means all of these numbers that were on the bottom are now going to be on the top. All of these numbers that are on the top are going to move to the bottom. So when I reduce, the 4 and the 7 are just going to switch places. Okay? Questions? All right, let's look at this next example. In the diagram, triangle BCD is similar to triangle RST. What is the scale factor of triangle BCD to triangle RST? Use the scale factor to find X. So this time I'm not trying to show that they are similar. I wouldn't be able to do that because I don't have any information about their angles. But I can already know that because it says right here, these triangles are similar. So I already know B is congruent to R. These two angles are equal. C is congruent to S. These two angles are equal. D is congruent to T. These two angles are equal. And then I know my sides are proportional, and I know they reduce to the scale factor. Okay? So if I start looking at my sides, BC, my first two letters here, that's going to match up with what? RS. Oops, I don't know what I just knocked out. Okay. Then when I look at my next two letters, CD, that's going to match up with ST. And then I look at my outside letters, BD, is going to match up with RT. And I know those are all going to reduce to the same thing. They're going to reduce to the scale factor. So then I'm going to fill them in. What is BC? 12. What is RS? So that's all I need for the scale factor. When it says, what is the scale factor, I can already tell you what the scale factor is. Because what is 12/24 reduced to? 1/2, 1 to 2. So that's telling me that this one is 1/2 the size of this one, scale factor. The one on top is half the size of the one on the bottom. Okay. So I've already answered the first part of this problem. It says find the scale factor. Already done. If this problem only asked me to find the scale factor, then I'd be done. I could move on. I don't even care about the rest of these fractions. I'm ready to go. I can move on. But unfortunately, this one does want me to find x. Okay? So if I continue filling this in, CD is 13. ST is x. And I know that 13 over x is going to equal what? 1 over 2. They're all going to reduce to 1 over 2. I don't have to fill this one in now because I have enough information to find x. But I feel like it's weird to just leave it blank. So I'm going to fill it in. BD is 5. And RT is 10. Which is just another verification that 5 over 10. Yep, 1/2. Yay. Okay. So now, to find x, all I have to do is take this 13 over x and say I know it's going to reduce to the scale factor 1/2. How do I solve that proportion? What did we do yesterday? Cross multiply. This is a really easy one to cross multiply because there's a 1 across from the x. 1 times x is just x. And 2 times 13 is 26. So x is 26. Easy peasy. Questions? Okay, let's look at the back. Alright, so looking at the back, let me zoom out a little bit. We have hexagon ABCDEF is similar to hexagon GHIJKL. Find the following. So then there's 5 things that they want me to find. Okay? The first thing they want me to find is what is the scale factor. Okay? So I'm going to find 2 numbers that I know. It's kind of real tempting to just go, oh, 16 to 9. Done. Reduce it, right? But we want to make sure that these are actually in corresponding positions. Okay? So if I were to look at the FE, does it match up with, what does it match up with? FE, my last 2 letters, matches up with KL. So FE matches up with, oh, it doesn't match up with this 9. It matches up with this one way over here. Right? So I don't know that these 2 go together. I have to make sure that the correct ones go together. So that's why it's really important to look at these, to make sure you're not just looking at this and going, oh, these 2 go together and these 2 go together. Okay? Because that's where you can get into some trouble. All right. So to find the scale factor, I'm going to first look at AB and GH. AB, C, D, E, F, 2, G, H, I, J, K, L. A lot of times what you'll see me do is I'll put an arrow, an up arrow in the first one, A, B, C, D, E, F, 2, so that I remember these numbers go in the top of the fraction, and then these numbers go in the bottom of the fraction. Not just so as I'm working these 5 problems, I don't forget which one goes where. So I know A, B, C, D is going to go in the top, G, H, I, J, K, L is going to go in the bottom. So AB is going to go on top. What is AB? 12. Over GH is going to go in the bottom. What's GH? 9. Oh, so these 2 actually go together, right? AB goes with GH. Well, that I can reduce, and then I know my scale factor, and I don't have to look at any of the rest of them. What is 12 over 9 reduced to?
4/3.
4/3. Don't forget, I got 30 calculators over here that reduced for you. So y'all can all reduce. So that is my scale factor. Okay. The next one, number 2, find LK. What is LK going to match up with? EF or FE? Yeah. So LK, this one here, is going to match up with EF or FE. So I've got a 16 here, and I don't know what this one is. That's what I'm trying to find is LK. Okay? Which one, the LK or the 16, is going to go on top? The 16, and that's easy to see because I put that up arrow, right? So the 16 is going to go on top over the LK on the bottom. What does that equal? 4 over 3. It reduces to the scale factor. They all reduce to the scale factor. And then this is easy to solve. All I have to do is cross multiply. Right? So when I cross multiply, I'm going to move over here to do it. I'm going to get 4 times LK is equal to 16 times 3. What's 16 times 3? 48. All right, and then divide both sides by 4. How big is LK? 48 divided by 4? 12. What are my units? Inches. All right, the next one, CD. What does CD match up with? IJ. So CD, I'm putting in pink, matches up with IJ, I'm putting in pink. Which one, the CD or the IJ, is going to go on top? The CD, because that's with my up arrow, right? So CD is going to go on top. IJ, which is 12 inches, is going to go on the bottom. What is this going to be equal to? 4 over 3. And then what do I do to solve? Cross multiply. Oh, these got all in order. Cross multiply. So when I cross multiply, I'm going to come over here to do it. I'm going to end up with 3 times CD is going to equal 4 times 12? 48. So how big is CD when I divide both sides by 3? 16. What are my units? Inches. All right. Number 4, find the measure of angle L. So angle L, L is my last letter here. So what's it going to match up with? F, my last letter here. All right, so angle L is here. Angle F is here. Which one's going to go on top? F is going to go on top. L is going to go on the bottom. Are you sure? Are angles proportional? Do they make a fraction? No, angles are congruent. That was a trick question. Neither one goes on top. They're not proportional. They're equal to each other. They're the exact same thing. So if F is 95, how big is L? 95. What are my units? It's an angle. Degrees. All right, and then the last one, the measure of angle J. J is right here. The third one in from the end. So what's it going to match with? D. So J matches with D. How big is angle J? 130. Angles are not proportional, they're equal. Measure of angle J equals 130. My units? Degrees. It's an angle. Questions? So be careful if you're finding angles, you don't have to set up a proportion. It's only when you're finding sides that you have to set up the proportion. Okay? Alright, next thing we're going to talk about is perimeters. What does it mean to be a perimeter? How do you find the perimeter of a shape?
It's the outside.
Yeah, it's the outside. You add up all the sides, right? So if we wanted to find the perimeter of this room, we'd have to measure all the walls and figure out how long each one was and add them all together, right? To find the perimeter of the room. Alright, if two polygons are similar, their perimeters are proportional to the scale factor between them. So all that's saying is if I take my two perimeters for my two similar shapes and I make them a ratio, I make them a fraction, they're going to be an equal fraction, that's what proportional means, to the scale factor. So it just means they're going to reduce to the exact same scale factor. Let me show you what that looks like on a problem we've already done before we do a new one. So when I come back here, if I look at this problem that we've already done and I find the perimeter of each of those two shapes, so remember perimeter, we just add up all of our sides, so that's all I'm going to do. Darken that a little bit. There we go. So I'm going to do 8 plus 8 plus 8 plus 12. My first perimeter is 36. And then if I do 14 plus 14 plus 14 plus 21, my second perimeter is 63. If I look at the ratio between them, remember we did A, B, C, D on the top. So this one on top, my 36 on top over my 63, it reduces to the exact same number that we got for our scale factor. That's going to be true anytime you have similar polygons. Okay? So let's apply that. Alright, so perimeters of similar polygons. Our first example, if quadrilateral KLMN is similar to quadrilateral PQRS, then find the perimeter of quadrilateral PQRS. Now if I didn't know anything about the perimeters being similar, I could set up a proportion here with the 8 and the 20 because KL matches with PQ to find the scale factor, and then once I know the scale factor, I could use that scale factor with sides and missing sides to find all the missing sides, add them all together, and find the perimeter of this bigger figure. But that means I'd have to do cross multiplication 1, 2, 3 times, and then after I did the cross multiplication 3 times, then I'd still have to add all of these numbers together. Okay? So we're going to use the fact that the perimeters are proportional to make this process go a lot easier. Okay? The first thing I need though is my scale factor. So I do need a scale factor. And the best way to approach this, if I didn't already tell you what matched up and you couldn't see what matched up, is look at the side that only has one number on it. If you have a side that only has one number on it, you're going to have to work with that side. That's going to be your only option, is to work with that side. So then when I look over here, I can make sure I know what it matches to. PQ matches with KL. And so these happen to be lined up nice and pretty. Not always the case, right? We saw that with the hexagons. And so then I can find my scale factor by looking at the ratio of those two numbers. Okay? So when I look at those two numbers, I need to decide what's going to be in my top and what's going to be in the bottom. Do you want to put the small one in the top or the small one in the bottom? Okay, so if I'm going to put the small one in the bottom, I'm going to put a down arrow. So remember, I'm always going to put that one in the bottom. And then I'm going to put this one in the top. Y'all are the first one today that's decided to go that direction. I like it. All right, so that means my 20 I'm going to put on top. And the 8 I'm going to put on the bottom. And then I'm going to reduce it to find my scale factor. What's my scale factor? 5 over 2. Okay? The perimeters will also reduce to 5 over 2. Okay? So now what I'm going to do is I'm going to compare my perimeters. So that means I need to find the perimeter of the little one because I know all of its sides. So I can do 8 plus 12 plus 12 plus 6. Let's see, 8 and 12 is 20. Plus another 12 is 32. Plus 6, 38. Is that perimeter? This perimeter, I don't know what it is. This is what I'm trying to find. Which perimeter is going to go in the top of my fraction? The x. The other perimeter is going to go in the bottom, the 38. What's that going to reduce to? 5 over 2. It's going to reduce to the scale factor. How do I solve this? Cross multiply. So when I cross multiply, I'm going to get 2 times x, which is 2x. What's 5 times 38? 190. So how big is x? 95. So that means the perimeter of PQRS is equal to 95, and we don't know what the units are, so we can just say units. Questions? Okay, let's look at a little word problem, because they're fun. A large cement rectangle is being poured for a courtyard in place of a smaller one. The courtyard will be 20 feet wide and 25 feet long. The old courtyard was similar in shape, but only 16 feet wide. Find the scale factor of the new courtyard to the old courtyard. Okay, so I can already see it's new to old. So I know I'm going to put the new on top and the old on the bottom. If I were just going to try to kind of sketch what the information that they've given me, the information they've given me is I'm making a large cement rectangle. The courtyard is going to be 20 feet wide by 25 feet long. The old courtyard, so this is the new courtyard, the old courtyard was similar, but only 16 feet wide. Find the scale factor of the new courtyard to the old courtyard. So I know, because it says new to old, I'm going to put the new in the top, and I'm going to put the old in the bottom. I didn't label this one, the old. Alright. On the old courtyard, the only thing I know about it is 16 feet wide. What is that 16 going to match up with? The 20, right? Because it's 16 feet wide and it's 20 feet wide. So I know those are my corresponding pieces, right? They're both the width of the rectangles. So those are the two I'm going to match up. Which one's going to go in the top of my fraction? 20. Which means 16 is going to go in the bottom, and that's going to reduce to my scale factor. What's my scale factor? 5 to 4. And notice I don't have any units there, even though it was 20 feet to 16 feet. Because it's feet over feet, the units cancel out. And what's nice about that is because then the scale factor of this being 5 to 4, it's 5 of any kind of units. So let's say that I measure the courtyard to do a fence or something around it, and the fencing comes in yards. then I can still use my scale factor of 5 to 4 with my yards or with inches or with whatever system I'm measuring with that day. The 5 to 4 will still work. It'll be 5 of whatever units to 4 of whatever units. Okay? All right, so I found the scale factor. A, done. B, find the perimeters of the new and the old courtyard. So the new perimeter is easy to find find its perimeter, right? The new courtyard, because I know it's 25, 20, 25, 20. What is the perimeter of the new courtyard? 90. 90 what? Feet. But the old perimeter, I only know the 16 feet. So I know this is 16 and this is 16, so I know that's 32. But I don't know the length, so I don't know the other. But I do know that the perimeters, if I set them as a fraction, they're going to reduce to the scale factor. Which perimeter is going to go on top, the 90 or the x? The 90, because that's where my up arrow is. So I'm going to do 90 over x, and I know that's going to reduce to the scale factor, which we said was 5/4. 5 to 4. How do I find x? Cross multiply. So 5 times x. 90 times 4. What's 90 times 4? 360. Divide both sides by 5. How big is x? 72. What are my units? Feet. So the perimeter of the new courtyard is 90 feet. The perimeter of the old courtyard was 72 feet. There we go. All right, you do have an assignment today. It is available to you in Schoology.